everyone. This is our project for EEE 304 lab course. We are group number 3. The name of our project is Catch Me If You Can. The objective of this game is to catch as many LED objects as possible within 30 seconds. The more you catch, the more you score. There are 7 main units in our project: shifter unit, control unit, display unit, reset unit, score unit, clock unit, and random number generation unit. We are going to describe each unit separately. This is the clock pulse generation unit of our project. Here we have used a 555 timer as an astable multivibrator to generate 1 Hz clock pulse. This is the main clock signal for our entire game. This is the Proteus simulation of our random number generation unit. For our purpose, we need to generate a random number from 0 to 7 at each clock pulse. Here we have used linear feedback shift register for generating pseudo-random numbers. For this part, we have used mainly 3 components: 4 D flip-flops, an XNOR gate, and a 3 to 8 decoder. The D flip-flops and the XNOR gate makes the LFSR to produce 4-bit random number at each clock pulse. Then we feed the 3 LSBs to the 3 to 8 decoder to produce our desired random number. This is the part of the circuit which controls the following objects. For this circuit, we have used 8-bit shift register with output latch. The output of each shift register is connected to a column of the 8x8 LED matrix. The output of the 3 to 8 decoder of the random number generator is set as input to the shift register. So, at any clock pulse, only one LED of each row will lit up. At each clock pulse, the shift register shifts the signal to the next row. There are 8 shift registers for 8 columns. Here we can see that at each clock pulse, the LEDs are shifted to the next row. Here only one shift register is shown. There are 8 shift registers for 8 different columns. This is the player's control circuit of the game. For this purpose, a up or down counter and 2 push buttons are used. Here we also used a Schmitt trigger to debounce the push buttons. When the up or down pin of the counter gets a pulse, its count increases or decreases by 1. This count is decoded by a 3 to 8 decoder, the output of which is connected to the LEDs of the player's row. So when count increases by 1, the LEDs shift to right, and when count decreases by 1, the LEDs shifts to left. For effective counting, when pulse is given at one clock pin, the other clock pin should be kept high. For this reason, pull-up resistances are used at the inputs of the up clock and down clock. This is the catch part of the circuit. Here we are using a 8-to-1 multiplexer and a tri-state buffer. The count of the counter is used as the selector input to the 7451 multiplexer. The corresponding input to the multiplexer are the last rows of the red LED. If both the LEDs are in the same column position, then the output of the multiplexer is high. But here the inverted output from the multiplexer is used to feed the tri-state buffer. If the buffer input is low, then the clock signal is passed to the score counter. Thus, one will get a point by catching an object. For counting the score, we used a BCD counter and BCD to 7 segment driver. The BCD counter is basically a modulo 10 decade counter that produces a BCD output code. The output of the BCD counter is connected to the corresponding input of the 7-segment display driver to display the count sequence on the 7-segment display. So this was our project Catch Me If You Can. We hope you enjoyed the game and liked our project. Thank you very much for watching our project.